Hello dear students. So welcome back to NEET 1. So today we will discuss the chemical reactions and equations, that is from your class 9th chemistry part. Okay. So now what actually the chemical changes or chemical reactions means? Okay. See, we are very familiar with many chemical reactions that are observed in our daily life. So in our daily life we will see many different type of chemical reactions because we are associated with these nature, right? So in nature many things happen and naturally, so they might be associated with some chemical changes, right? So we need to know, we need to study those reactions, how they are happening, what might be the reasons, okay, whether they are useful to us or whether they cause any damage, or how they harmful or how they useful for us. We need to have some clarity on these things right now. Okay. So now tell me one the best well known example of a chemical reaction that you have seen in your like in your daily life. So the best example, you might be very much like interested or like to eat chips or any food material, right? So now what happens if we keep that food material for longer time or for a side? So what happens, the smell of that food changes, maybe color of that food might get changes, right? So what is the reason here? Because whatever the food we are seeing, that will be getting oxidized. When it get oxidized, its color maybe changes, its color, maybe the smell also changes, maybe the taste also changes, okay, and it also get sometimes it also get spoiled, okay, it will also get converted into a spoiled item, okay. So it is not good for taking also, it is not good for eating also. So why the reaction here, generally the associated chemical reaction is here the oxidation. What is that process called? Oxidation, okay. Now let us see some other example also. See, we know the iron rod, if you take any iron or metal piece, what happens if you place that in the anywhere at your home site? So after few days if you observe, that iron get damaged, like you are seeing something like some kind of the plates are coming out of it, some bubble kind of things you might be observing. So now what happening to that iron? So whatever the metal piece is there, that iron is there. So iron, if you take Fe, so it will be converting into its iron oxide, like iron oxide we will get, okay. So like Fe2O3 kind of some oxides will be formed. So this is called rusting of iron. What is that process called? Rusting. Now what happening? See, an iron element like metal converting into its oxide form. So now what you are seeing, to this iron metal we are adding some oxygen, right? So this process is called oxidation process, okay. So rusting means what? The oxidation of any metal to its oxide. The process can be called as oxidation. Particularly in the case of iron, we can say it as rusting. What we can say? Rusting. So this is how the metal, the utensils or whatever we are seeing might get damaged after some days because of this rusting process, right? Now you may also get one more doubt. Sir, not all the iron, all the metal items get rusted, but only few. For example, this iron metal utensils, whatever the material we are seeing, sometimes it get rusted right now. But if you see something like copper metal utensils or any materials, so that won't get rusted easily, that much easily as we seen in the case of iron. Or you take any stainless steel. So stainless steel is nothing but it's an alloy, okay. So now this won't get damaged by the oxygen when it is exposed to atmosphere. So what is the reason here? Yeah, so this iron might be having more chemical reactivity compared with the copper, and this is steel, okay. So this is how you need to interlink to your daily life applications also. So now one more thing, when you take simple iron rod or any iron material without any coating on it, that particular utensil or particular material get rusted very easily right now. But if you coat it with some color, like you just take an iron metal and you coat it with some iron, any color. Now what happens, that whatever the color painting we are doing, that whatever the painting we did, so that will protect iron metal from the oxygen or any other atmospheric gases, so that the rusting of iron can be prevented or it can be reduced. It means the shelf life of that particular material will be increased. See, all these things are what? Associated with our chemistry only, na? So that is the thing we need to study about chemical changes and what are the chemical reactions that should cover at your level of class, I mean at your 9th standard level. Okay, we will go through this very clearly. Okay, and once after completing this session, I will also be connecting it to the higher level like JEE NEET level of questions, so that you can enjoy this and also you can make your preparation for higher level exams also. Okay, right. So the first thing, whenever I say chemical reaction, whenever I say chemical reactions, you should indicate something like this. So this arrow mark is indicating conversion of something like this. For example, I have some A and B type of starting material. Starting material means like I should say this as a reactants. What I should say? Reactants. It means what exactly reactants means? You will start the reaction now. You need to do a reaction means you need to take some initial compounds, right? Then only you need to add one into another, so the reaction takes place right now. So these can be our starting materials. You should call them as what? Reactants. So now what happens? These reactants will combine with each other. Okay, some kind of change, some kind of reactions happens, and finally gives you something called product. Okay, so this conversion is indicated with an arrow mark. So this side you should say product and this side you should say reactant. Okay, and now see, during this reaction, some starting materials may be in different physical state. For example, if you take iron, so this is in solid state right now. Now you are adding some acid like H2SO4 or HCl, okay, to this. Okay, so let us say I am taking something like H2SO4, sulfuric acid I am taking. So now what happens is, like generally iron is in solid form, sulfuric acid in liquid form. Now what happens? This iron and this sulfate reacts and forms ferrous sulfate, iron sulfate. Okay, and here two hydrogens are there now, so those things come out as H2 gas, hydrogen gas. Okay, so this is aqueous, you can say. So now what is happening here? So if you take this solution like liquid state now, so this becomes aqueous. So now what is happening here? See, during a chemical reaction, their physical state might changes. Okay, so during a chemical reaction, it can be during a reaction, it can be a physical change or it can be a chemical change. Whenever I say physical change, there is no change in the composition. For example, water I am taking, water which is in the liquid state. Now what I am doing, I am heating it. What happens? Is there any chemical change is taking place? No chemical change. What happens? The physical state of water changes from liquid to something like a gas, like H2O gas. So now what it is associated with? Some physical change only. So physical state, liquid converted into gas now. So this is considered to be a physical state. Whereas here if you see, these two substances are reacting and forming new compounds, right? So these can be considered to be a chemical change. Okay, yeah. So in a chemical change, the physical states also varies, like solid might be converting into here aqueous right now. So this is liquid, that is becoming gas. So physical states may also changes. Now just read this point that I have given here in the table, small boxes. So what this first box saying? Once read it, everyone read this. Once I will check whether live is going well or not. Any doubts in the comment boxes? Yeah. Okay. Yes. Then next after this, just read the definition of this. What is a chemical change means? A chemical change is a change in which one or more new substances with different properties are formed. See, this is a metal, iron, and here acid, sulfuric acid. So these two are now considered to be starting materials. Those are nothing but our reactants. So now these are having some kind of properties. The products formed this side after this arrow mark, these will be having different chemical or physical properties right now. So once again read, a chemical change is a change in which one or more new products, one or more new substances, right? Formed here, one or more new substances. Yeah, so these are formed with different properties. So do they have same property or different property? Yeah, these are having different property. Why? like sulfuric acid is an acid, but here this is something like a salt and hydrogen gas is formed. So they will be having different properties and they will be having different properties. Okay. Now look at the physical change also. No new substances are formed. Example, melting of ice, or like here you can see melting of ice or boiling of water. All this comes under what? Physical changes only. Okay. Then next, you can see chemical change. One more thing here. What do we mean by chemical change? Formation of new compounds will be observed. New substances are formed. For example, rusting of iron, burning of magnesium. See what happens, burning of magnesium means you take a magnesium ribbon, okay, you just like light it up. So what happens if you take it to the Bunsen burner? So what happens is magnesium metal, which is in solid substance, it's a metal, no? So it's a solid in form. Okay. So now what happens when it is exposed to air like oxygen? So it converts to MgO, magnesium oxide. Okay, this is also like a powder substance. So magnesium oxide. So now here it is gas. So try to balance the equation. So 2 magnesiums, 2 oxygens, okay, and here 2 magnesium oxides. So this is how you need to balance the equation also. So what happens in a chemical change? A new substances are formed. Yes, a new substance is formed now from magnesium metal, oxygen gas, giving a new substance like magnesium oxide, right? So it is having solid state, the physical state as solid. Okay, so this is one of the example. And one more example, if you see curdling of milk. So that is also a daily life example in which the chemical process is taking place right now. Yeah. So the next one here, read some more things to be known while we are writing a chemical reaction. So the first one again, mean the science of chemical reactions. Okay, so science, for science means what? Like you need to indicate the chemical reaction in a specific manner. Something like you need to indicate their physical state, okay, and what is the color change taking place, what is the color change taking place during the reaction, okay, and you need to see whether the compound formed is precipitate. Precipitate means any solid mass is formed, okay, like a powder substance, okay, you can expect that, we will see that later, precipitate, okay. Then next, what is the temperature change associated during the reaction, okay. Then next, whether we are using anything like light or sound for conversion of this reaction, or what will be the smell that we are observing before and after the completion of chemical reaction. Okay, let us generalize this using some ABCDs. So like A and B are, let us say A and B are starting materials combining to form some product C plus D. Okay, like this let us understand. Okay, so now what I am saying, maybe the physical state of A is a solid, yes, you can put it as S, so indication of physical state. Okay, next, maybe the physical state of B is gas, let us put it as G, and let us put the physical state of C as L, means it may be liquid, okay, and this may be solid or something, let us put like that. Okay, and while writing the chemical reaction, for example, here you are seeing solid now, it might be formed as a precipitate. So if it is forming as a precipitate, you should write it as arrow mark downside. Okay, so what do we mean by precipitate? Means something like some insoluble mass will be formed as a product. Okay, so that will be observed at the bottom of the test tube. Okay, if you are doing a chemical reaction in a test tube, what happens? You will add substance A, substance B. Okay, that chemical reactions may change, takes place, and at the down you might be seeing something like powder substance like deposited at the bottom of the test tube. Okay, so that is considered as precipitate. So it is an insoluble solid may form. Okay, you just remember like that. I will show you what exactly precipitate in the upcoming sessions with one example of chemical reaction taking image. Okay, now during the reaction, maybe our starting material may be having some yellow color, product may be having some green color or red color, like this chemical during a chemical reaction color changes may also be observed. Okay, next, here one more thing, temperature change. For example, during a chemical reaction, sometimes heat might be released. If heat is releasing, you should say that reactions as exothermic reactions. It means what happens is, see, you are doing the chemical reaction in this test tube. Okay, So you are adding like you are adding A and B in this reaction, I mean to this test tube. Now what happens between this A and B chemical reaction takes place, and it may form some product like this. So during the formation of product, it may release heat outside of the test tube. So it is releasing heat now. If you touch it, you will feel hot. Okay, some reactions will be there, they will only absorb the energy, that heat energy from outside. So it means if you touch the test tube, you will feel it cold. Why? Because it is only absorbing the heat right now. So those kind of reactions are called endothermic, exothermic. Once again, endothermic means that reaction only absorb heat from outside. Okay, and exothermic means that reaction only releases energy to the outside of the test tube. Okay, exothermic means releasing of heat, endothermic means absorbing of heat. You can remember this. Okay, now if you want, you can absorb. You can do it at your home also. You can try it with the help of your parents. Now what you will take is, you take one test tube and take some lime powder. I mean, like what I can say, like we'll use it for painting now. Okay, otherwise if you are not having that, you just take a chalk piece. Okay, you just dip it in the water. So how do you feel? At least a little bit sensation you will feel, that heat change sensation you will feel. You just absorb it. Okay, yeah. Next, and you know, there are some chemical reactions that won't takes place in lower temperature, they require suitable temperature, or some reactions will be there, they only happens at lower temperature. For example, I am saying this reaction may takes places 100 degrees Celsius only. It means if I provide only some 20 degrees Celsius like this, the reaction may not happens, because for this particular conversion, how much temperature must be maintained? 100 degrees. So that you should mention here, and the arrow mark you should write like this. What is the suitable temperature for the conversion of this particular chemical reaction? Okay. Then next, some chemical reactions will be there, they will be happens only in the presence of light. For example, the best process is photosynthesis, that we will see in our daily life. See the green plants, if you observe, the leaves will be like this now. So in these leaves there is something called magnesium metal, okay, in the chlorophyll pigment. Okay, so this chlorophyll pigment, that magnesium metal is there now, so that will take the sunlight, that will absorb the sunlight, and that will initiate the chemical process, the photosynthesis process. Okay, so which is very very important for like they will absorb the CO2, converts into glucose and releases oxygen, all this process is there now. So with the help of what? By the absorbing of sunlight only. It means that for that particular process, what is required? Light is required. Like that, for specific reactions, specific conditions must be maintained, that you should mention on this arrow mark. For example, this reaction, sunlight is used now, so you mention either sunlight or you just mention it as H nu. Okay, or you mention it as sunlight, just write sunlight on the above the arrow mark or below the arrow mark. Okay, and the next one more observation you can do during the chemical reaction is, there may be change in the smell of the reaction. For example, here if you observe what I am writing, Fe metal, upon treating with acid, something like HCl if you take. So now what happens? HCl if you take, so now what happens? It will forms FeCl2 plus H2 gas is released. What happens? H2 gas is released. This is one type of chemical reaction. Now you might not be seeing any type of chemical reaction, I mean any type of smell change much, but there will be releasing of these bubbles. So if you do this reaction in the beaker, let us take this is a beaker having this solution. Now what happens? Let us say this is a liquid material, all this chemical reaction is taking place. Now what happens? That H2 gas is there now, so that will comes out like upside like this, like a bubbles. So now looking at the bubbles, you can observe, yeah, maybe some kind of gas is releasing during the reaction. Okay, now we are discussing about odor now, like odor means smell. So for example, here I am taking FeS, okay, ferrous sulfide I should say. What is that? Ferrous sulfide. So upon treating this with hydrogen like HCl like this, now what happens is, it releases FeCl2, I mean it forms FeCl2 and H2S gas is formed. See, 2 hydrogens and 1 sulfide. So what is forming product? H2S gas is formed. So this H2S gas, hydrogen sulfide gas, is like I am saying gas now. So whenever you write gas, you can indicate this arrow mark. It means what? Yeah, that gas liberates outside from the test tube or whatever the reaction material, I mean flask you are taking. So now this gas has very bad smell, like rotten egg smell we should say. So what is the smell of this? Rotten egg smell. So whenever you are doing this reaction, you will see very bad smell, like rotten egg means, I think you got what do we mean by rotten egg smell. So if there is any spoiled egg, what kind of smell we may expect, I mean we may experience. So same way you are going to see the similar kind of smell when H2S gas is releasing. Okay, right. I hope it is clear. So what are the things we may observe during a chemical reaction? So chemical reaction may associated with gases evolved or formed, or maybe sometimes we will see color changes, okay, and precipitate also may be formed during some reactions, and temperature also changes, okay, light. Some reactions may require specific condition like sunlight or some sound rays, waves or something like that, right now. And then next, new smell may be formed. Starting material may not be having any smell, but after formation of product we may see some smell. Okay, this is the best example. Okay, and even in the spoiling of food, what I told you, the food gets spoiled means that oxidation is taking place. The product is now having smell, but initially there is no smell, right? So these all associated with what? The chemical reactions only. Okay, right. Okay, so let's move forward. Okay, now what I told you, so there is something like reactants. In a chemical reaction there is something like reactants and there is something like product. Okay, so starting material in the reaction is called reactant. The final product formed, the new substance formed in the reaction is called product. Okay, so now during this reaction, during this transformation, what happens during a reaction? What happens? The atoms, whatever the atoms are there here, they get rearranged. For example, let us see what is this reorganization or rearrangement means. See, I am writing a chemical reaction, that is combustion of methane gas. Okay, what I am taking? Combustion of methane gas. When you burn something like fuels or hydrocarbons like say methane, it will gives you carbon dioxide gas. What gas it gives? Carbon dioxide gas, and also water formation takes place. Water vapors will be formed. So now during this reaction, see, carbon atom, starting material, in starting material carbon is associated with hydrogens, right? But in this side, the product side, carbon is now reorganized or rearranged with the or recombined with the oxygen, right now. Means these atoms, whatever the left side atoms we are seeing, they may get reorganized or rearranged when it is converting into product side, right now. This is what the chemical reaction taking place. It means during a chemical reaction, no new atom is generated. What I am saying, during a chemical reaction, no new atom is generated. They will only, whatever the atoms present at left side, they get reorganized or they get rearranged. It means what? How many carbons we have this side? 1, right? So here also it is 1. Okay, here you are seeing how many hydrogens? 4 hydrogens now, but here only 2 hydrogens you are seeing, means you just multiply it with 2. Okay, then next, so total how many oxygens you are seeing? Here it is 2 and here it is also 2. So total oxygen atoms are 4. So here also it should be 4. It means 2 2s are 4 oxygen atoms. So this is called a balanced chemical reactions. In a balanced chemical reaction, what I am saying is the total number of atoms, whatever the atoms we are seeing at the reactant side, same will be present at the product side, but they may get rearranged or reorganized. Reorganized means, I hope it is clear. See, carbon is reorganized to combine with oxygen and forming CO2. Hydrogen combining with oxygen forming H2O. So this is what? Atoms get rearranged, bonds may break or new bonds may form. The bond between carbon hydrogen here got broken and a bond between carbon and oxygen might get formed here. So a new, like old bond gets broken and new bonds get formed during a chemical change. Okay, I hope up to here it is clear, right? Yeah, then next. Yeah, so the chemical equations, that whatever I have mentioned here, this is called chemical equation. So these chemical equations are two types. How many types? Two types. One is word equation, the other one is symbolic equation. So what do we mean by word equation? You are just writing the chemical reaction in the word format. Word format means, like I can say magnesium is combining with oxygen and forming magnesium oxide. So this is called word equation. What is this? Magnesium, this is called word equation. Magnesium combining with oxygen forming magnesium oxide. So in this case, how to write? ఈ కేసులో ఎలా రాయాలి మనం? Methane combining with oxygen, methane plus oxygen giving carbon dioxide plus water molecules, like water you should write. Okay, so those are called word equations. These are what? Word equations. Okay, but when we are going for higher level, instead of writing these word equations, we prefer only symbolic equations. What is it? Symbolic equations. So symbolic equations includes the symbol of that each element involving in the reaction. So for magnesium, the symbol is Mg. Okay, for oxygen, the symbol is O2. Okay, so whenever I say oxygen, you should take it as O2. Okay, instead if I mention only as oxygen atom, you should take oxygen atom. If there is no like a mention of this atom, then you should take it as O2, because in nature oxygen will be in the O2 format, right? So you should write O2. Okay, then write the arrow mark. Okay, so the next, magnesium and oxygen combines upon burning, so it will gives you magnesium oxide. Okay, next what I told you, there should be same number of atoms at reactant side and product side. Left side, right side, same number of atoms undaలని cheppanu kada. So how many oxygens are there here? 2, right? So they here also it should be 2. Okay, if it is 2, magnesium also to be 2. So this is 1. So this is how you need to write the equation, symbolic equation. Okay, now here I used something like symbol like this delta symbol, right? So this delta symbol indicates we are using heat during the reaction. Say combustion reaction, we are burning during the reaction, that is what delta indicates, heat. It indicates heat. Okay, next, what I told you, the left side of the arrow mark are called reactants. The starting materials are what? They are called as reactants, and the right side are called what? Products. Okay, I hope up to here the basics are clear, right? Yeah, let's move forward. Now these chemical reactions are of different types. Okay, like first one is combination reaction. What is it? First one is called combination reaction. So what do we mean by combination? The name itself saying now, like something like starting materials will be there, they will combine with each other, like A and B will combine to form a final product like AB. Okay, the best example is carbon combines with oxygen, forms carbon dioxide like CO2. Okay, see what is happening in the reaction? They are combining now, starting materials are getting combined to form a final product. Okay, so you can see here in the simple way, two or more substances combined, like 2 or more than 2 might get combined to form a single product. The product side, how many should be there? Only one single product should be there. Okay, like A, B combining to form final product as AB. Okay, there are sometimes it may be A, B, C, multiple reactants are combining, but the product formed should be only one, that is like A, B, C only. Like here C plus O2 combining to form CO2, right? So this is only single product should be formed. Okay, and one more example here I mentioned, like calcium oxide plus water combining to get calcium hydroxide. What it is forming? Calcium hydroxide. See, single product is formed right now. So single product is forming means you can say these two are combining to give a single product. So you can say it is an example of combination reactions. So once again, when you are writing your exam, your answer should be like first, what is the definition of a chemical reaction? Okay, then next, write the chemical reaction, then indicate that reactant gives rise to product equation. Okay, then next, types of chemical reactions, in the types of chemical reactions, first one is combination reactions, right? Write the combination reactions as heading, write this basic definition. If two or more reactants combine, it gives you final product, only one final product, okay? Then the best example you can remember, C plus O2 gives rise to CO2, okay? And when you are writing this now, it is really good if you mention their physical states. For carbon, what is the physical state we have? So it is solid. For oxygen, it is gas. For CO2, it is gas. Like this, you should mention physical states also. And we know this reaction is a like burning reaction, like combustion reaction. You can also mention delta symbol if you want. Okay? Yeah, this is the perfect representation. And if you want one more reaction, you can take calcium oxide plus water forming to give calcium hydroxide. Okay, that's it. Next. So what is the clue I am saying for this particular reaction? For combination reactions, combination reactions means you should get many reactants, one product. What I am saying? Many reactants, one product. That is what the combination reactions. Okay, right. Okay, the next reaction is decomposition reaction. What is it? Next, decomposition reaction. You just read the definition once. Okay, so now see what is this decomposition reaction says. Once read it. So one compound breaks into simpler substances. Like combination we have seen something like in combination multiple compound substances combine to give one final product. In decomposition, one starting material gives multiple products. Okay, you can remember like that. Okay, so first let us see. For example, I have a compound like ABC. So if this ABC is a compound, it may decompose like A plus B plus C or something like this. You will get multiple types of products from this starting material only. So just see once, one compound breaks down into two or more simpler substances is considered to be decomposition reactions. Okay, the best example here is calcium carbonate. So calcium carbonate, upon heating, what happens is calcium carbonate upon heating. So now what happens, it gets decomposes. It means it will form calcium oxide like CaO and CO2 gas will be produced. What is produced? CO2 gas will be produced like bubbles you can see if you are doing it in the water state, liquid state. Okay, so this kind of reaction, see one starting material giving more than one product right now. Next, one more example you can say. This is called calcium carbonate. Upon heating gives calcium oxide plus carbon dioxide. Mention their physical properties also, physical states also, solid, a solid, and this is a gas. Okay. Okay. So the next, potassium chloride like KClO3. One more example I am giving you. This is enough, but I just want to add one more example. Potassium chloride, upon heating, what happens is, so you take two KClO3s. Upon heating, what happens, this KCl will be formed plus how many oxygens you are seeing, 3 to the 6 now, so 3O2 will be formed, so oxygen gas will be released. Okay, so like this you can understand about decomposition reactions. Okay, then next. Okay, so we have some other types of reactions like displacement reactions, okay, disproportionation reactions, all these are there. We will discuss them in the upcoming session. So stay connected with our NEET World YouTube channel. Thank you. ఎందుకురా వచ్చి డిస్టర్బ్ చేస్తారు?